Good morning, all of you. Today we are going to start with the very first session of the day, and of course it is the last day of the training, and I hope you are enjoying the training. So we are going to begin with very first session with the honorable guest, Dr. K.S. Patel ma'am. She is an associate professor in VGC Chandkheda. She is having his BTech from SVNIT Surat. She is having master's degree in computer science from LD of engineering. She is a degree. She pursued her PhD from Gujarat Technological University. Welcome, ma'am, on the behalf of Computer Engineering Department of Government Polytechnic Gandhinagar. Welcome, ma'am. And as the topic of the day is regression algorithm, and we are having a really good opportunity to learn from such a degree. So without wasting any precious moment, I would like to hand over to honorable guest, Dr. K.S. Patel, ma'am. Please, ma'am.
Thank you, sir. Am I audible?
Yes, ma'am, you are.
Sir, can you see my slides?
Yes, ma'am, it is clearly visible.
Okay. Good morning, all of you. In today's session, in my session, we are going to learn a machine learning algorithm which is used for data science. In this session, I will discuss the regression algorithm which can be used for prediction as well as the classification. The regression algorithm is used for prediction and classification. That will discuss how the algorithm is modeled, means how model is created using regression, and I will show you the implementation of the same in Python. You already know the definition of data science during last 4 days. It must be covered. So data science is something, it is a process which gives you knowledge or insight from the huge, after processing huge data set, you may get processing as well as analyzing huge data set, you may get some knowledge or insight. Means after processing and analyzing data set, you will get, you can predict something from the data set, you can divide that data set into some groups, or you can classify them. Okay. Um, these are the steps science based project. If you want to implement any data science based project, you have to follow these many steps. Your first step is you have to find out the problem. That means if you want to predict the weather, if you want to predict the temperature, then for that is your goal. Okay. Classify your email whether it is spam or not. So that is the goal. So you have to first identify your goal. Then to achieve your goal, you have to collect the data. Okay, so you should have a large data set to solve your problem. Then after getting data set, you have to study that data set, or you have to do pre-processing. What pre-processing will does? So it will, during the pre-processing, you have to look into the data set and find out if something is missing, if some values, there may be possible that some values some values are missing in your data set. So you have to deal with them. You have to handle them. Either you may remove them, either you or you may add some default value. Okay, so that is how you can handle the missing values while data processing. The next step is data enrichment, which is also called feature engineering. So while during feature engineering, you have to find out the relationship among various features. Feature is nothing but the column of your data set. Okay, whether a specific column is important for your solving your problem or not. It may possible that you are having 15 columns, but out of those 15 columns, only 5 columns are important for you. Same way, if there are 2 columns, and from those 2 columns, if you are deriving something, some new thing which is important for your problem, so you can create new feature, you can remove the features as per your requirement. So that is the fourth step. At the end of the fourth step, your data set is completely ready for analysis. Okay. So after fourth step, you have the fifth step is data visualization of your data. So in fifth step, you are drawing, you are plotting your data using any graph. Okay. So what is the why we are plotting the data? So by looking at the graph of your data set, you can identify that whether you are going to use whether your data set is linear or non-linear. If you found that your data set is linear, you may use linear algorithm uh, for processing that data or for analyzing that data. Okay, machine learning algorithm can be linear, they can be non-linear. So based on the relationship among the features of your data set, you have to decide the algorithm. That which algorithm, there are a lot of machine learning algorithms. So which algorithm you are going to use for processing or for analyzing your data. Okay, so that will be decided after visualization of your data. And the last step is what? Actually use your data set for modeling any machine learning algorithm, and then predict. If your algorithm is regression based algorithm, then predict the value which you want. Let's see, if you want to predict temperature. So after creating a model using machine learning algorithm, you may predict the temperature. Okay. Or you may find out the relationship among two features. So that is the last step. In today's session, we are studying about the sixth step. Okay. So machine learning algorithm. So what is machine learning machine learning? So machine learning algorithm is nothing but a computer program which learn from experience. Experience is nothing but your data set, historical data which is stored inside your data set. Okay, so machine learning algorithm is a computer program which learn from experience with respect to some task. Task means what? Your goal. If I want to predict temperature, then prediction of temperature is my task. Okay, so a program is created which learn from my data, from the data set with respect to some task. Now while learning from the experience, whether I am learning correctly or not, measuring that, a performance measure is required. So I have to learn, or I have to, yes, I have to train my program from the data set in such a way that performance is improved. Okay, performance is degraded, then I have to take some step so that the performance of my learning algorithm is improved. Okay, so machine learning, it is a program, a computer program that will learn from the experience E, that is your data set, with respect to some task T, that is your goal, and some performance measure P, in such a way that performance on T as measured by P improves with experience. The performance should be improved during the learning. Okay, so that is a machine learning program. Now machine learning algorithms are classified in three categories based on its learning style. They are the supervised machine learning algorithm, unsupervised machine learning algorithm, and the semi-supervised. Third category is semi-supervised. In supervised machine learning algorithm, your data set is having label, or your data set is having response variable or a target variable. That means what? In your data set with features, a response value is also given. That means what? If you have collected data set for classifying email, whether it is a spam or not, so you are collecting some features of with feature inside your database, it is also given that whether with that feature your email is spam or not. Okay, so target value is already given with inside your data set. So that is called the labeled data set. So in supervised machine learning algorithm, labeled data set is used. While in unsupervised algorithm, the data set is not labeled. Only features are given. Okay. with feature, the target value or a response value is not given. So if your data set is having no label, you can use unsupervised machine learning algorithm for analyzing them. Supervised machine learning, the example of supervised machine learning algorithm are regression algorithm and the classification algorithm. Unsupervised machine learning algorithm are clustering algorithm. The third category is semi-supervised machine learning algorithm, in which your data set is, some of your data sets are labeled and some are not labeled. Okay. And the example of semi-supervised machine learning algorithms are the algorithms which are used to create game. Means if you are training computer to play game, then in that case you have to use semi-supervised machine learning algorithm. Okay. So that is about the types of machine learning algorithm. Okay, now in today's session, as I have told you, we will discuss the regression. So what regression algorithm does? So it models the relationship between feature variables and the target variable. Feature variables are also called the independent variable, and target variables are also called the dependent variable. So in regression model, a function is modeled, a function of independent variable is equal to the target variable. Okay, so that function is modeled, which is used to predict a real value. Means regression algorithm or value. Okay. During regression, means while we are training our model using regression model, it iteratively refines, iteratively improved in such a way that error is okay. So after each iteration, error value is calculated, and it will see that after each step, error should be reduced. If error is increased, then we have to tune our model in such a way that in next iteration, error is reduced. Okay, and it will stop when it reached to minimal error or the lowest error. How we can do that, that we'll discuss further. Here in regression model, in any machine learning algorithm, the data set is also called the training set. Now these are the various notation which we are going to use in our further discussion. M is the size of the data set, that is the total number of records in my data set. X, X is used to note the features or the input variables. Y is used for output variable or target variable. Now, if our data set is having m number of data points or m number of records, then to identify ith record, we are going to use X, I, Y, I. Now, here I must be put as a superscript. Then H is used to note the function or the hypothesis, which is a function which accepts X and produce the Y. Okay. Now this is the regression algorithm. The input is the data set or a training set. The regression algorithm use this data set for learning the algorithm, and the outcome of that learning algorithm is the hypothesis, that is the function of X. Sorry, function y of Y in term of X. Okay. So after that, after creating that hypothesis, now I can use to predict Y for any unknown X. That means if I have a function, by putting any X value, I can get the Y value. So that is how I can predict Y from from any unknown X value. Okay, now regression algorithm can be of two types. It can be simple, it can be linear or non-linear. Regression algorithm can be linear and non-linear. Linear regression algorithm is used when the relationship among the features are linear. Means your features are linearly they are linear. Okay, they are linearly distributed. The linear regression algorithm again can be of two type. It can be simple linear regression algorithm and multivariate or multiple linear algorithm, linear regression algorithm. If Now we'll start with the simple linear algorithm. In simple linear regression algorithm, the feature there is only one feature, means only one feature is used and one target variable. Okay, and your hypothesis function is theta 0 plus theta 1 x, where x is a feature variable. Okay, and theta 0 and theta 1 are the parameter using which you can tune your model. Okay, now what is the goal of simple linear regression? So the goal of simple linear regression is to find out the best value of theta 0 and theta 1 such that the cost is minimum for your training data set. Now what is cost? So cost is the difference between actual value of y and the predicted value of y. In simple linear regression, we have to find out this equation. Let's say theta 0 is 0.5, theta 1 is 0.5. So 0.5 plus 0.5x is the function which we have find out after training our model, simple linear regression model. Okay. Now, after finding out this function, for any value of x, let's say in our data set, we have a x is equal to 1. And for that x, we have a label y equal to 1. So 1, 1 is our data set. Training, okay, in our, 1, 1 is a data point in our training set. So for that data point, now if we want to predict, then what we have to do, we have to put x into this model 0.5 plus 0.5 x. So here if we put x is equal to 1, I will get 1. So our predicted value is 1 and our y value is also 1. So there is no error. The difference of that data point is 0. The difference of predicted value and the difference of actual y value, target value. Okay, so that is 0. So for that specific data point, there is no error. Now, if let assumes that the second data point is 2, 2. X value is 2, Y value is also 2 for second data point. Okay. Now for this, if I want to predict, I have to put X is equal to 2 in my model. So 0.5 plus 0.5 into 2. So that is equal to 1.5. So our predicted value is 1.5 and the actual value is 2. So the error is 0.5. Okay, so that is how I have to estimate the value of theta 0 and theta 1 in such a way that there must be minimum error for the training set. Means after finding out value of theta 0 and theta 1, I have to put all x values from my training set and find out the h theta x, that is the predicted value of y, and then find out the difference of y value which is there in the data set and that the predicted value, and then I have to do sum of them. That is called the regression model. Clear? Here in a graph you can see that this is a sample example. Here you are having total 5 data point. First is 1, 1, second is 2, 2, third is 3.3, 4 is fourth data set is 4 and 3.75. Fifth data point is 5 and 2.25. Okay, so these are our actual data point. Now let's say I have estimated theta 0 is equal to 0.5 and theta 1 is equal to 0.5. So my model, simple regression model is 0.5 plus 0.5x. That is my hypothesis. Okay, now after out the model, what I have to do, I have to the value of y using different x, because x is my feature. Okay, so I'm using x is equal to 1 and putting that x into my function. So I'll get the predicted y. Same way, if I put 2, My predicted, yes, for 2, this is my predicted value, and this difference is the error. For 3, this is the predicted value, and this difference is the error. For 4, this is the predicted value, this is the actual value, so this is the error. Same way for 5, this is the predicted value and this is the error. Okay, so this is the example only. Here I am taking theta 2, theta 0.5, theta 1.5. So if I am taking this 0, I'll get this error. For 1, there is no error. Okay, so what simple linear regression model does, it will find out the optimal value of theta 0 and theta 1 in such a way that this error, some of these errors should be minimum. Okay, so for estimating value of this parameter in simple linear regression, there are two solutions, there are two methods. One is the least square estimator. The second is the gradient descent. Okay, so using these two methods, you can optimally estimate the value of theta 0 and theta 1. Now, how this two technique works, least square estimator and gradient descent, that we'll discuss. Okay, so the first one is the least square estimator. So least square estimator, in this method, the value of theta 0 means this method derives the equation of theta 0 and theta 1 in term of x and y, because we have a data set, we have a training set is having what, x and y. Okay, so value of x and y known to us, so least square estimator will do what, it will find out the equation of theta 0 and theta 1 in term of x and y in such a way that the cost value, the value of cost function is minimum. Okay, so that is the goal of least square estimator. In least square estimator, the cost function is sum of square residual. Okay, this is the cost function, and least square estimator will try to minimize, or it minimizes function. Okay, now what is residual is nothing but the difference of predicted y and the actual y. And the cost function is defined like this, a square of residual. So sigma I is equal to, okay, 1 to m, means for each data point in your training set, you have to find out the predicted value and find out difference of that predicted value with the y value, that is the residual, and then you residual sum them for each. Okay, so this is the cost function which is used in least square estimator. This cost function should be minimized. Okay, now here if we are substituting the value of h theta x, then we'll get this, h theta x is equal to what, so it is equal to theta 0 plus theta 1 x. So we are putting that value in this equation, so we are getting theta 0 plus x theta 1 minus y whole square. So this is our cost function. Okay, now we want to minimize the cost function. So for minimizing the cost function, we are using optimization technique, in which we have to do partial derivation of this cost function with respect to theta 0 and theta 1. So the first is what? Partial derivation of this cost function with respect to theta 0. So that is equal to, if we do partial derivative of this equation with respect to theta 0, we'll get 1 here, 0 here, 0 here. But before that, we have to do 2 into this function and 1. Okay, so we'll get what? 2 into our function into, for theta 0 we'll get 1, for this 0, for this 0. Okay, so this is the partial derivative of cost function with respect to theta 0. Same way, we'll do the partial derivative of the cost function with respect to theta 1. So that is equal to 2 into our function, and then do derivative of each term with respect to theta 1. So for theta 0 it is 0. For this it is xi, and for y it is 0. So we'll get xi in multiplication. Okay. So this is the partial of cost function with respect to theta 1. Okay. Now what we have to do, we have to put this partial derivative equal to 1. So we'll get two equation. The first equation is sigma I is equal to 1 to m theta 0 plus xi theta 1 minus yi is equal to 0. We are putting this is equal to 0. Partial derivative is equal to 0. So that is so we'll get this equation. And for we are putting partial derivative of this also equal to 0. So we are getting this equation. Okay. Now we have two equations and two unknown. We want to find out what theta 0 and theta 1. X and y are known to us. So we are having two equation and two unknowns. So two equations will find out the equation of theta 0 and theta 1 in term of x and y. Okay. So we'll try to solve the first equation. So this is our first equation, that is sigma theta 0 x theta 1 minus y is equal to 0. Now if we here this equation is equal to sigma theta 0. I am separating my terms. Okay, so sigma theta 0 plus sigma xi theta 1 minus sigma yi. Now theta 0 and theta 1 are the constant value, they are the real value. Okay, so sigma of theta 0 is nothing but m times I am adding theta 0. So that is nothing but m of theta 0. Okay, here I am taking theta 1 outside. So we have a sigma of xi minus sigma of yi is equal to 0. Now we want equation of theta, we'll derive equation of theta 0 in term of theta 1. So m of theta 0 is equal to, I am taking sigma y and sigma x right side. So that is equal to sigma y minus theta 1 sigma x. Then I am theta 0 is equal to, I am taking m to right side. So that is equal to sigma y upon n minus theta 1 sigma x upon n. Now sigma y is nothing but the mean of or the average of y. Sorry, this whole term is mean of y, and this is mean or average of x. Okay, so theta 0 is equal to y bar, that is mean of y, minus theta 1 mean of x. So equation of theta 0 in term of theta 1. Clear? Now what we have to do, we are taking the second equation. Now we want to solve this equation. So in second equation, if I am putting the value of theta 0, I will get the equation of theta 1 in term of x and y. Okay, so I am doing that thing. So this is my second equation. I am substituting the value of theta 0 in this equation. So I'll get this. Now I am rearranging, means I am arranging the terms. Theta 1, I am putting theta 1 terms together and y terms together. Okay, and they are multiplied with xi. Okay, now here I am separating them. So I am putting sigma in both the term. Sigma xi yi minus y bar minus sigma theta 1 xi into xi minus x bar. Okay, now I am putting this term to right side. So we are having sigma theta 1 xi into xi minus x bar is equal to sigma xi into yi minus y bar. Now I want to find out theta 1. So theta, I'm taking out theta 1, taking theta 1 outside the sigma. So theta 1 is equal to sigma xi yi minus y bar upon sigma xi minus x bar. Okay, now I am replacing xi with xi minus x bar at numerator as well as the denominator. So that is equal to this equation. Now this equation, you can see that the upper term is nothing but the equation of covariance and the lower term is the equation of variance. Okay, so the upper term is denoted by sxy and the lower term is sxx. Okay, so the theta 1 is equal to covariance upon the variance. So this is the equation of theta 1. Here you can see that you of xi, the value of average of x, the value of yi, the value of average of y, again xi and average of x. So all values are known to us. So from the training set, we can find out the theta 1, and if after finding out theta 1, we can find out the theta 0 equation. Okay, so these are the equation of theta 0 and theta 1 in least square estimator method. So if you are using least square estimator method in simple regression, linear regression model, then the equation for theta 0 and theta 1s are this. Okay, so this is what a least square estimator is. Now, after finding out the hypothesis, we need to check the performance of our model. Because while discussing the machine learning definition of machine learning algorithm, I have shown you that you have to estimate your model for solving your problem in such a way that after each iteration, performance should be improved. So how can we measure the performance of our model? So in regression model, the performance is measured by these two matrices. First is the root mean square error and the second is R2 error, or the coefficient, it is also called the coefficient of determination. So how can we calculate root mean square error? Uh, for finding out mean square error, means the square error is what? The sum of, the difference of and the real value and square of it, and we have to do summation of this for each data point. So that is the square error. Mean square error means what? If we divide that square error with total number of data points, that is m, then that is the mean square error. And root mean square error means what? If we find out the square root of that, that is the RMSE. Okay, so root mean square error, this is used to measure the performance of your model, and this should always be less. The value of this matrix should be, if less RMSE, your model is better. Second is the R square error. R square error is nothing but the normalized mean square error. Okay. R square, the equation of R square is equal to 1 minus, this is nothing but the square error upon y. Okay. The value of R square is always between 0 and 1. Okay. And if the value of R square is large, your model has better performance. Okay, so that is how you can measure the performance of regression model. Now, the example. Let's say we are having, okay, here I am taking a small data set, or data set which is having only 5 samples, 5 data points. So this is our feature X and this is our target variable Y. So for X1, is equal to 7. For x2, we have y is equal to 14. For x3, y is 15. For 4, y is 18. And for 5, y is 19. Now what I want to do, I want to create a simple linear regression model for this data set. So what I have to do, if I am using least square method, I have to use these two equations for estimate the value of theta 0 and theta 1. Okay. So the equation for theta 1 is what? Sum of covariance upon sum of variance of x. Okay. So how can I find out them? So I have to first find out mean of x, that is equal to 3. Then mean of y, that is equal to 14.6. Then I have to find out y minus y mean and x minus x mean. So x minus 3, 1 minus 3, 2 minus 3, 3 minus 3. Okay, so that is how I have find out this column, x mean column. Then y mean column is difference of y and y mean. So this is how I have find out this column. Then after, for theta 1, the numerator is what? Y mean, y minus y mean into x minus x mean. Okay, so that is sxy. I have multiplied this column with this column. That is nothing but the sxy. That is the numerator. Then we are doing sum of them. Sigma sxy. Okay, sigma x minus x mean into y minus y mean. So we have to do sum of them. That is 28. So that is the numerator. The denominator is what? Y, x minus x means square. So I am doing x minus x means square. That is our sxx. And then we have did sum of that. That is 10. So this is the denominator. So theta 1 is equal to 28 upon 10. That is equal to 2.8. Okay. So using least square estimator, we have estimated the value of theta 1. Now theta 0. So theta 0 is equal to what? Y mean minus 2.8. That is the theta 1. X, that is 3. So from this equation, we'll get the value of theta 0 is 6.2. So our regression model is what? H of theta x is equal to 2.8x plus 6.2. That is theta 0 plus theta 1 x. So this is our estimator. So using this estimator, we have estimated the value of y, or we have predicted the value of y. Okay, this is the actual value of y in our data set. This is the value which we have predicted after creating a model. Okay, so now what we have to do, we have to measure the performance of our model. So for that, what we have to do, we have to find out the error. Okay, that is nothing but the difference between these two terms, y actual and y predicted. Okay, so this is the residual. These are the square of residual. Okay, so mean square error is what? Square of residual upon m. M is equal to what? Total number of data set. That is equal to 5. Okay, so 10.8 upon 5 is equal to 2.16. So that is our mean square error. Root mean square error means what? Square root of this. So that is root mean square error. And r square is equal to what? 1 minus 1 minus square, that is 10.8 upon y mean square. So this is the y mean square, and we have did sum of them. So upon 89.2. So that is the R2. So the value of R2 is 0.87. So what does it mean? That our model is performing 87%, means our prediction is 87% better. Okay, our model is designed in such a way that it will give it will predict the value 87% better. Okay, so you can say that the performance of your model is 80, means 87% of times it will give correct predicted value. Okay, so this is how the simple linear regression model is created using the least square estimator technique. Okay, our regression line. Okay, if you look at the model, if you look at these h theta x functions, so that is nothing but a function of line, equation of line. In equation of line, what is equation of line? X plus c. So slope of your line and theta 0 is the y. What is theta 0? It is y intercept, means your line y. So if you look at here, this line 2.8x plus 6.2. So that line is drawn as a black line here. So this is our estimator. This is our model, regression model. And these blue points are our actual point. Okay. So our regression model is y is equal to 2.8x plus 6.2. R square is 0.878 that we have already calculated here. Okay, so how simple linear regression will estimate? So we have a value of y known to us for x is equal to 1, x is equal to 2. If I want to find out the value of y, if I want to estimate or predict the value of y for 1 is equal to 1.5, I can predict it using this line equation. Okay, so that is how you can predict value of y for unknown x using this model. Clear? Okay, now I'll show you implementation of them in Python. Can you see the program?
Yes, ma'am.
Okay. Here in Python, we have created an array x and y in which the value of x is 1, 2, 3, 4, 5. That is what value we have used in our example. The value of 14, 15, 18 and 19. M here instead of m, I have used variable name n. So n is the size. We have computed the mean of x, mean of y, then sxy and sxx, that is equal to what? Sum of this sum function will do the summation of the complete array. Okay, so sxy xsx is calculated. Then after the b1 is calculated, that is nothing but the sxy upon ssx. Then b0 is computed, that is y mean minus b1 into x mean. Then the value of this theta 0 and b1 is nothing but the theta 1 and this is the theta 0. So value theta 0 and theta 1 is printed. Then here this code will just print. It is used to plot the x and y. Okay, plot the value of x and y in a graph. Then we have used this model. We find out beta 0 and beta 1. So we are using that model to find out to predict the value of y. So y predict which stores the predicted value of y. And actual value of y is stored inside this y array. So y predict and y, this is used to compute the error. Okay. So after plotting actual x and y, we have plot the predicted x and x and the predicted y. Okay. Then for computing error, as I have told you, we are finding out difference of y and y predicted. Then we have did sum of that is the square error. Then mean square error is sum divided by total number of data set. Then root mean square error is square root of it. And then R2 is equal to 1 minus square error upon variance of y. Okay. So this is how we have implemented the thing which I have shown you in slide in Python. Okay, so this is our program and this is the output. So value of theta 1 is 2.8, value of theta 0 is 6.2. Then these are our actual data point. This is our predicted line. This is our model. That is nothing but 6.2 plus x 2.8, that line. Okay. The square error is 10.8, mean square error is 2.16, root mean square error is this, and the value of r square is this. Okay, so you can implement the simple linear regression using least square estimator. Now, if you want to compare this value with the built-in, then this is the code. Instead of using our program, I am using the linear regression model, which is available in sklearn library of Python. Okay, I am using the same data set and then regression model with dataset x and y to fit the model. Then predict function of that model is used to predict the value of y. So we have a y predict. Now I can use them to find out the errors. So error for that also some functions are readily available in Python. Okay, so here everything is calculated or find out using the built-in function. Now if I run this program, you can see that here in built-in regression model, the value of theta 0 and theta 1. So intercept is what? Theta 0. Coefficient is theta 1. So regression model dot co, if you print regression model dot coef underscore, that will give the value of slope, that is the theta 1 and theta 0. So for that you have to use regression model dot intercept, so that will give 6.2, that we have already calculated in our algorithm also. Mean square error is 2.16, that is same as the same value as we have calculated. This is the root mean square and this is the R2. Okay. So this is the built-in function which implements simple linear regression. The same model is used for simple as well as the multivariate linear regression. Okay, so this is all about least square estimator and its implementation in Python. Now, as I have told you, there are two techniques. One is the least square estimator and second is the gradient descent. So gradient descent is the other method which is used to find out the value of theta 0 and theta 1. Now in gradient descent, the cost function is same cost function, mean square estimate, mean square error function. But here they have used 1 upon half of that mean square error function. Okay, 1 upon 2m and then square error. Our goal is what? To find out the value of theta 0 and theta 1 in such a way that this cost function is minimized. That means the error should be minimized. Now, in gradient descent, this gradient descent algorithm has two steps. First step is what? Start with any random value of theta 0 and theta 1. I can start with theta 0 is equal to 0, theta 1 is equal to 0. And then after iteratively change the value of theta 0 and theta 1 using some technique that we'll discuss further, and find out the cost. Now, the value of theta 0 and theta 1 will change in such a way that after each iteration, the value of cost should be reduced. Okay, and we'll repeat this step until we'll find out the local optimum, means the lowest cost value or minimum cost value. Okay, so how can we change the value of theta 0 and theta 1 with gradient descent? So for that, gradient descent algorithm use these two equations. Though it is simple linear regression, we have a theta 0 and theta 1. So theta 0 is equal to theta 0, that is the previous value of theta 0 minus alpha into partial derivative of cost function with respect to theta 0. And theta 1 is equal to theta 1 minus alpha into partial derivative of cost function with respect to theta 1. Okay, that is the rule of gradient descent. What gradient descent will do. Okay, now here alpha is it is called a learning rate. Alpha is used for what? It is used to control the size of steps. Matlab it is used to control the reduction in theta. Okay, how it works that we'll see later. So alpha is a learning rate and this is the derivative of cost function. Okay, now why we are using partial derivative? So in this graph, you can see that if we plot cost function with different value of theta, we'll get this curve. Okay, this is the graph of cost function with different value of theta. Now, if I assume that, means if initial value of theta is this, theta 0 is this, okay, then derivative of j theta 0 is nothing but the slope of tangent drawn on that point to my cost curve. Now, if you see that the slope of this tangent is positive, okay, so theta 0 is equal to minus alpha into some positive number. That is the slope of tangent. Okay. Now, if you multiply that positive number with alpha, alpha is also positive. So you will get a positive number. So theta 0 is equal to theta 0 minus some positive number. So you will find out a theta 0 which is less than the your value of theta 0. So you are moving toward the minimum. Okay, your minimum is here. Minimum cost is here. You assume theta 0 is equal to this. So after first iteration, you are moving towards the minimum. Now at this point also, again I have to find out theta 0 is equal to theta 0 minus alpha into derivative. So derivative is nothing but the slope. So in second iteration, again slope is positive. So alpha into positive number is again a positive number. So I am decreasing the value of theta 0. So that will be, let's say here. So after each iteration, you are decreasing the value of theta 0. And at some point you are reaching over here, that is the less minimum function, and here you have to stop. Same way, if I start with this theta 0, because you can start with any value of theta 0. Okay, you have to randomly choose the value of theta 0 in first step. So if I take this as a theta 0, then theta, the equation is theta 0 for next iteration, theta 0 is equal to theta 0 minus alpha into derivative. So derivative is nothing but the slope of tangent. Okay. So here you can see that the slope is negative. So minus alpha into some negative number. So minus alpha into negative number will be the positive number. So the value of theta is increasing in this case. So in next iteration, you will get increased value of theta. That could be this. Then in next iteration, again the value of theta is increased because the slope is negative. Okay. So ultimately, after some iteration, you are reaching to the local optimum or the minimal, the point where the cost is minimum. Okay. So that is why derivative is used to find out the value of theta 0. Clear? Because if you are using derivative, after some steps, you may reach to minimum cost. Okay, and that is what our goal is. We want to find out the theta 0, value of theta 0, where the cost function is minimum. Okay, so that is what about derivative is. Now next is the learning rate. Now what is learning rate? So it is number. Now what learning rate will do? So if we take learning rate very small, then it will ultimately decrease the value of this term alpha into derivative term. Okay, so if alpha is very small, you are taking very small steps, means it takes large number of iteration to reach toward the minimum cost function. Okay, and if learning rate is very large, then it takes large steps, means it may possible from here you may reach here, from here in next iteration you may reach here, from here in next iteration you may reach here, from here from next iteration you may reach here. So it may possible, if alpha is very large, it may possible that after some iteration you never reach to local minimum. Okay, you are moving from here to here, here to here, here to here, so you will never reach to local minimum, means minimal cost function. Okay, so your algorithm may never converge if the value of alpha is very large. So alpha is what? Learning rate. It is used to control the step size. Okay, so the value of alpha should not be too small. If it is too small, then your gradient descent will take large number of iteration. So the convergence is slow. If alpha is very large, then it may possible, it takes large steps. I mean, it increase value of theta or it decrease value of theta in large term. Okay, so in that case, it may possible that you will never reach to the value of theta 0 with which cost is minimum. Okay, so what should be the value of learning rate? So the value of learning rate should be, it could be find out by by trial and error method. Okay, you start with 0.01 or 0.02 or 0.03, then find out the cost function, this cost function curve. Now if with 0.001 you will not find out the decrease in cost after each iteration, you may choose alpha is equal to 0.001. With alpha is equal to 0.001, if you find out the decrease in cost after each iteration, then that is the right choice for you. Okay, so you have to choose alpha in such a way that after each iteration, the cost function should be reduced. If it is not reducing, that means there is a problem with your alpha. Okay, so how can we use gradient descent with linear regression? So as I have told you, this is my model. This is the cost function, and this is what a gradient descent technique used to find out the value of theta 0 and theta 1. So you have to start with any random value of theta 0 and theta 1 and use this equation to find out the next value. Okay, but for that what you have to do, you have to do derivative of your cost function with respect to theta 0 and theta 1. So that is nothing but the derivative of 1 upon 2m sigma h x minus yi square. Okay, so if we do derivative of this equation with respect to derivative of this equation with respect to theta 0 and theta 1, what we'll get? We'll get this equation. Okay, this is the x square. So the derivative of x square is what? 2x. So 2 will be eliminated. Okay. So you will get 1 upon m, this function. Here I have substituted the value of theta, h of theta x. That is theta 0 plus x theta 1. So this is the derivative of cost function with respect to theta 0. And this is the derivative of cost function with respect to theta 1. Okay, this is not there. So our theta 0 is equal to theta 0 minus alpha into this derivative, and theta 1 is equal to theta 1 minus alpha into this derivative. So these are our equation. So what we have to do in our algorithm, if I want to estimate the value of theta 0 and theta 1, I have to start with some random value of theta 0 and theta 1 and then find out the cost. Okay. Then using this equation, find out the next value of theta 0 and theta 1, again find out the cost. Okay, you have to repeatedly do this thing until you find out the minimal cost. Whenever you are finding out minimal cost, that will be your final value of theta 0 and theta 1, and you are getting your model that is equal to theta 0 plus x theta 1. Clear? So this is how gradient descent works. Now I will show you implementation of it in Python. Okay, so in Python, again, I have used the same data set. Can you see the program? Hello?
Yes, ma'am, it is visible.
Okay, so this is our array. This is M. Okay, now initial value of theta 0 and theta 1, I have taken them 0. So theta is equal
Kashif
to...
ma'am, please
Huh?
increase the font size.
Okay. Okay, so here I have initialized theta 0 and theta 1 as 0, 0. This is our hypothesis function, means after value of theta 0, after setting value of theta 0 and theta 1, for finding out cost value, I have to put that theta 0 and theta 1 into hypothesis function. So that it will give me a predicted value. And then I have to compare that predicted value with the actual value of y. So this is the hypothesis function which gives me a predicted value of y with given x and theta 0. Then this is the cost function that will find out the cost of error. Not cost means what? The error. Okay. So for that, I have to predict the value using theta and x and then find out difference of that predicted value with actual value of y. Okay. So that this is this mean square, this is the square error and upon 1 upon 2m. So 2m. So this is the cost function which I have shown you in this slide. 1 upon 2m sigma h of theta x minus y whole square. Okay. So that I have implemented here. Okay. Now this is the gradient descent. So as I have told you, it is an iterative function. So in gradient descent, I have theta, that is what initially it is 0, 0. Then x and y, this is our data set. Epoch, that is the number of iteration. How many times I want to run the gradient descent. Alpha, that is the value of learning rate, which I have told you that it should be from 0,001 to 1. So you have to test if you want to set it. Okay. Then cost is, it is an array which stores the cost after each iteration. Then we are running a loop. So in loop, what we have did, we have first find out the predicted value of y. So for that we have used hypothesis for given x. Okay. So for each x, we have find out the predicted value of y using the theta which we have set. So initially it is 0, 0. Then using the equation which we have derived, we are finding out the value of new theta 0 and theta 1. So theta 0 is equal to theta 0 minus alpha into this. And theta 1 is equal to theta 1 minus this. Okay, so these two equation we have already derived in our slide. So this is nothing but the implementation of them. Then what we have did, we have calculated the cost using new theta. Here we have calculated the new theta. So we are computing the cost of it and into one array. Okay, so we are repeatedly doing this thing. We are in each iteration the value of theta is modified and the cost is calculated, and that cost will be added into the cost array. So the gradient descent will run the gradient descent and gives you different value of theta. Okay, and then we are return this gradient descent function returns the value of theta and the cost of each iteration. Now predict function, so it accepts the value of theta, your data set x and y, number of iteration you want to run gradient descent for, and the value of learning rate. Okay, so this predict function will call the gradient descent function by passing the initial value of theta, x and y, the data set, number of iteration you want to run, and the value of alpha, and it returns the predicted value, cost, and theta. Okay, so these are the definition of function. Now we are actually function in this line. Okay, so we have call a predict function with initial theta value, that is 0 0, our data set. I want to run gradient descent for 2000 iteration. So epoch is equal to 2000 and my learning rate is 0.01, that is the alpha. Okay, so what this function will do, the predict function will call the gradient descent function. The gradient descent function will find out the theta and cost. Okay, and using that theta, I can predict the value of y. Clear? So after this predict function will, whatever value will get in theta, that is the value, estimated value of theta 0 and theta 1, which will be found out by the gradient descent. Okay. This is how, this is the code which plots the actual xy and the predicted xy. Okay, so I'll run this code. So in this program, what I have did, I'm just I'm just estimating the value of theta 0 and theta 1 using gradient descent. This takes some times because we are running gradient descent for 2000 times. Our epoch size is 2000. This is the output. This is okay. So for see, we have used gradient descent with the same data set. We have the same data set we have used with least square estimator. Okay, so the output of this program is here. The blue dots are the actual value of y, and the orange dot are the predicted value of y. Okay, and here I have plotted the cost function also. So when theta 0 and theta 1 are 0, the cost is very large. And after each iteration, I have run 2000 iteration. Okay, so after each iteration, you can see that the value of cost is reduced. Okay, and at some point, at this point, at 750, after 750th iteration, value of cost will be constant. Okay, and you can see the value of theta 0 and theta 1, that is same as estimator. Theta 0 is 6 and theta 2 is 2.84. Okay. So this is how you can estimate the value of theta 0 and theta 1 using gradient descent method. Okay, now one more thing, if you are using gradient descent method, your feature must be normalized. Means if the value of your feature is in term of thousand or in term of lakhs, then you should scale them to either between 0 or 1 or -1 to 1. Okay. Not doing that thing, your gradient descent method will take a very long time to converge. Okay. So for running your gradient descent faster, you have to normalize your feature vectors. So how can you do normalization? So there are two techniques. One is you can divide your each feature by its maximum value, or the second method is mean normalization, in which you have to subtract mean value from your xi and divide it with the range of your feature value, feature vector. Okay. So these are the two methods which can be used for feature scaling, and it is required when your feature value of your feature is very large. Okay, now second is the multivariate regression. Okay, up to this we have discussed the simple regression in which there is only one feature. Now multivariate regression. So in multivariate regression, more than one features are used to predict the value of target variable. Okay, so your data set will look like this. Here we are having total 4 features and price is the target value. So what this data set is about, we are predicting the price using size of house, number of bedrooms in house, floors, number of floors in house, and the age of that house. Okay, so these are the features which are used to predict the value of that house or the price of that house. Okay, and for that we are using this data set. So we are having total 4 features. So if features are greater than 1, it is called multivariate regression or the multiple regression. Okay, so now while modeling multivariate regression, we have introduced one more term, that is N. N is what? Number of features. M is number of training example. X of I is ith training example. So let's say X2, X superscript 2. So that is equal to the second row of my data set. Okay. Now X22. So X22 is what? Second feature of second record of my data set. Okay. So these are the notation which we are going to use in our further discussion. Okay. So now in multivariate regression, our hypothesis function is changed. Earlier in simple regression, we are using up to these only because we are having only one feature. Now we are having n number of features. So our hypothesis function will be h of theta x is equal to theta 0 plus theta 1 x1, theta 2 x2 up to theta n xn. Okay. So for simplicity, I have used here x is 0 also. So theta 0 x0 plus theta 1 x1, theta 2 x2, theta n xn, where here x0 is always equal to 1. Okay. Now I can represent this equation using vector, where x vector is equal to x values x0, x1 up to xn, and theta vector is having value theta 0, theta 1 up to theta n. So now in term of vector, my hypothesis function is theta transpose x. This is the matrix multiplication, theta transpose into x. So if I am doing theta transpose and multiply it with x, I will get the same function. Okay, theta 0 x0 plus theta 1 x1 and so on. So the hypothesis of our model is this. Our parameters, now here what we have to estimate, we have to estimate value of all theta. Theta 0, theta 1, theta 2, theta 3 up to theta n. And our cost function is the same cost function as we have used earlier. Okay. So in multivariate regression, for estimate the value of thetas, gradient descent method is used, and the same method, same equations are used, but here theta 0 is equal to theta 0 minus alpha 1 upon our error function into x0i. Now here you already know that x0 is equal to 1. So the same function as the simple linear regression. Then theta 1 is equal to theta 1 minus alpha 1 upon m, and this. So this is same as the simple linear regression. Now in simple linear regression, you are having only 2 theta. But in multi-regression, we have to calculate theta 2. So theta 2 is equal to same alpha 2 minus alpha 1 upon m, sigma I is equal to 1 upon m, h theta xi minus yi x2i. Now how I have got this equation? So these are nothing but partial different derivation of differentiation of this equation with respect to theta 0, this is with respect to theta 1, this is respect to theta 2, and so on. Okay, so these are the equation. Now the implementation of multivariate regression. So it is same as the simple regression, but here the value of not only theta 0 and theta 1, but all theta will be derived. Okay. The program I will show you after completing the logistic regression. So this is all about multivariate regression. Okay, now while discussing regression model, means while modeling your data set using regression model or any other model, if you create a model by following only training data set, and if you directly use it to predict the value for unknown features, then sometimes it may possible that your training is you have did training perfectly, you are getting performance value, performance matrices also very good for training data set, but sometimes it may possible that whenever you are giving unknown value for unknown features value for predicting target variable, it may not give you correct value. That is because of the overfitting problem. So what is the solution of overfitting problem? If you want to solve this overfitting problem, you have to divide your data set into two: training data and testing data. The training data is used to train your model, same as we have did previously. And after training the model, you have to test the performance of your model by giving the X value of test data set, and then compare that Y predicted value with the actual value of Y of the test data. Okay. So if you are after creating your model, if you are testing it using test data, you can actually find out the performance of your model. Okay. And then after, you may use that model to predict the unknown value. Clear? So that is the use of training, dividing your data set into training data and testing data. That is used to solve the overfitting problems. Okay. So up to this, we have, this is all about the regression model. Okay. Which is used for predicting the real value. Now, second algorithm of supervised machine learning algorithm is the classification problem. Classification problem are used to solve the problems like classification of email, whether the incoming email is spam or not, if some transactions are going on in bank, then it can be used to classify whether that transaction is fraudulent or not. Okay, so classification is generally used to predict the categorical data. Okay, whether the weather is cloudy or rainy or cold. Okay, so, and regression is used to predict the value. What is the value of temperature? What is the value of specific stock? Okay, so for predicting the value, regression is used, while classification is used to predict the categorical values. Okay, now during our discussion, I will discuss about binary classification only. Binary classification means what? You are having only two class, whether class 1, one means class 2. Means if I want to classify whether an email is spam or not, so I may use 0 for spam email and 1 for not spam email. Or I may use 0 for not spam and 1 for spam. Okay. So this is what a classification is. Now for classification, we can use regression, and the algorithm which is used regression for classification is the logistic algorithm. In logistic regression algorithm, we are using the regression. That means we are using our hypothesis function, which is there in linear multivariate as well as simple regression. Okay, that is equal to what? Theta transpose x. That is theta 0 x0 plus theta 1 x1 plus theta 2 x2 up to theta n xn. Okay, now what is the requirement for logistic regression? That our regression function should be created in such a way that it gives value between 0 and 1. Why? Because our classification problem has target value either 0 or 1 in case of binary classification. So we want h of theta x in between 0 and 1. Now how can we do this thing? So for that we are using logistic or sigmoid function. So here gz is a sigmoid function that is equal to 1 upon 1 plus e raised to z. And the graph shown in this slide is the graph of sigmoid function. So how this sigmoid function works? So if the value of z is any positive number, the output is z is what? The value greater than 0.5 and less than 1. So it should be between 0.5 and 1 for any positive number. Okay. For any negative number, for any negative value of z, the value of zz is what? The value between 0.5 to 0. Okay. And for value z is equal to 0, when z is 0, gz is 0.5. So this is our sigmoid function. So what we have did, we want h theta x between 0 and 1. So if I pass this h theta s function into G, then I will get what I will get. I will get the value in between 0 and 1 because G function, this sigmoid function always give values between 0 and 1. Okay, so that is why our hypothesis function for logistic regression will be G of theta transpose X. Means what? I am passing this theta transpose S function into G. So now my hypothesis will be what? 1 upon 1 plus e raised to minus theta transpose x. Okay, so this is the hypothesis for logistic regression. The logistic, how now logistic regression works? So if h of theta x is greater than 0.5, then we are predicting 1. And if h of theta x is less than 0.5, we are predicting it as a 0. When theta x greater than or equal to 0.5, so whenever this x, that is theta transpose x, is greater than or equal to 0, h of theta x will be greater than or equal to 0.5, and so y is equal to 1. And when this theta transpose x is less than 0, h of theta x is less than 0.5 and y is equal to 0. Hello, lecture માં શું પછી કરું? Okay. So we can define a decision boundary in logistic regression. So this is the example of two features, x1 and x2. We are having two features in our data set and we want to do logistic regression. And now suppose first we have plot our data set on x1 and x2 axis. So these are our data point. Now how these data points are separated? With the help of decision boundary. So as per logistic regression model, which we have discussed earlier, when y is equal to 1, so whenever our theta transpose x is greater than or equal to 0, y is 1. Whenever theta transpose x less than 0, y is 0. So these are the two categories. Okay. So what is the decision boundary? Theta 1 plus theta 1 x1 plus theta 2 x2. That is theta transpose x is equal to 0. That will be the decision. That is the separation line. All things which are greater than that value or on that value will be 1. All things which are less than that value will be 0. Okay. So theta 1 x1 plus theta 2 x2 is equal to 0 is our regression line. Sorry, is our decision boundary. So that is nothing but the function of line. Theta 1 x1 plus theta 2 x2 is equal to minus theta 0. So that is the equation of line. So in case of two feature, the data points are separated by a line. So whatever which is data points which are falls below the line are of category 1, and whatever data points falls above that lines, they are of category 2. Okay, so this is how for two feature the decision boundary is a line. For three feature, decision boundary will be a plane. So whatever the data points which are below the plane, they are of one category, above that plane are of the other category. Okay, so that is how decision boundary is defined in logistic regression. Now now in logistic regression also, if we want to model it, we have to find out the thetas. Okay, we have to find out the values of theta for model. So how can we find out the value of theta? Using gradient descent. Now, if we want to use gradient descent, we should have a cost function, because what gradient descent will do, it will estimate the value of theta in such a way that cost is minimum. Okay, so we should have a cost function. So the function of classification is a binary cross entropy cost function. Okay, so here the cost function of linear regression cannot be used. For classification, the cost function is different. So the cost function is what? Mean of binary cross entropy cost function. So that is equal to what? Minus log of h of theta x for y is equal to 1, and minus log of 1 minus h of theta x for y is equal to 0. That means what? If my actual class is 1, if my actual y is 1 and predicted y is also 1, then cost is what? Minus log 1. That is equal to what? 0. Why 0? Because I have predicted correct. Correct value is 1 and predicted value is also 1. So I have did correct. I have classified correctly. So the cost is 0. But if my correct value is 1 and I have predicted 0, so in that case, the cost is minus log 0, which is some infinite positive number. Okay, that means cost is very large if I have wrongly classified, if I have misclassified. Same way, if y is 0 and I have predicted 0, then the cost is log 1, which is 0. If I have correct value is 0, and if I have predicted 1, that is what I have misclassified. Then in that case, cost is minus log 0. That is some large positive number. So the cost is very large if I have misclassified. Okay. So this is why this binary is used to calculate the cost of classification. Okay. Now for simplicity, what we have did, I want to add this both term in my, I want to combine this both term in my cost function. So what I have did, I have multiplied this with y. So when y is 1, this will be the cost function. When y is 0, this term will be 0. So in that case, 1 minus yi, 1 minus 0. So 1 into this will be the cost function. Okay, so I have just combined these two terms by multiplying it with y and 1 minus y. Okay, so when y is 1, this is the cost. When y is 0, this term will be, okay, when y is 1, this term will be 0. And this is the cost. 1 minus 1 is 0. Okay, when y is 0, and this will be our cost. Okay, so this is our cost function. Now, gradient descent, that is used for estimating the value of theta in logistic regression. So what we have for initially we have to initialize all theta with some initial value, it could be 0, and then we have to repeatedly run our gradient descent, and in each iteration we have to reduce the value of, we have to change the value of theta, and we have to continue this until you find out the minimum cost function. Okay, so for doing that, the same thing is used. Theta is equal to theta minus alpha into derivative of our cost function with respect to theta. Okay, so for theta 0, this will be derivation of cost function with respect to theta 0. For theta 1, derivation of cost function with respect to theta 1, and so on. Now, if you do derivation of this equation with respect to theta 0, you will get sigma 1 is equal to, sorry, sigma I is equal to 1 to m theta 0 x of I minus yi x 0. Now x 0 is equal to 1. Okay. Now if you do derivation of this with respect to theta 1, you will get theta 1 is equal to theta 1 minus alpha sigma 1 I is equal to 1 upon m h of theta xi minus yi x j of 1. Okay. So the same equation which we have got with linear regression. But the difference, only difference is what? Here in linear regression, your h of theta x is what? Theta 0 x 0, theta 1 x1, theta 2 x2. While in this case, your h theta xi will be what? 1 upon 1 plus e raised to minus theta transpose x. Okay. So we have to use this function in logistic regression. So that is only the difference. That is only difference between linear regression and logistic regression. Gradient descent of linear regression and logistic regression. Okay. Now I'll show you implementation later if time permits. Otherwise, I will send you the programs. Okay. So during lab session, you can see them. If you have any doubt in program, you can send me an email. You can ask. Now the performance of classifier. In regression, the performance can be measured using root square error or R2. While classification, performance of classification algorithm cannot be measured by accuracy. Why? What is accuracy? Accuracy is equal to correctly classified sample divided by total number of sample. Okay, let's say in my data set, I have 100 data points. Okay, and out of 100 data points, suppose 90 data points are classified as 1 and 10 data points are classified as 0. Now, if I am using accuracy to for this model, and if my model is h of theta x is equal to 1, I have not calculated the value of theta 0 and theta 1. I am just writing what h of theta x is equal to 1. Then for the data set which I have told you, I will get 90% accuracy, though I have not implemented the model. Okay, so that is why accuracy is not used to measure the performance of classifier. So what is the solution? So for classifier, for finding out the accuracy of classifier, confusion matrix is used. Okay, so a confusion matrix is created if I have total 100 data points, and out of 100 data point, let's say 50 are of one type and 50 are of zero type. Okay, so and out of those 50, okay, now here the matrix is created like this. The columns are predicted no matlab 0 and predicted yes means predicted 1, predicted 0, predicted 1, and actual 0, actual 1. Now suppose actual 0 data points are 50. Out of 50, let's say predicted 0. We have a 50 data point of 0 type. Out of 50, suppose 40s are predicted correctly. So true negative is equal to what? 40. 10s are wrongly predicted. So false positive is 10. Clear? Out of 50 data point of negative type, 0 type, 40 data points are correctly predicted and 10s are wrongly predicted. Same way, if my actual data points, 50 data points are having, they are of one type. Okay. And out of them, let's say 30s are predicted as 1. Then predicted yes is equal to 30. And 20s are falsely predicted. Okay. So this is how my confusion matrix is created.
I'm sorry to interrupt you.
Yes.
Ma'am, actually we are having another session at 12 p.m. and then if a participant may have a question, answer, ma'am, please. So please try to wind up as soon as possible, ma'am.
Okay. Okay. So this is how you can create a confusion matrix. Now, as I have told you, accuracy cannot be used to measure the performance of classification. So what we are using recall and sensitivity. The equation of recall is equation of recall is true positive. That means correctly classified value upon true positive plus false negative, means actual true values and correctly classified true values. Precision is correctly classified true values upon predicted true values. These are recall the denominator is actual true values. Okay, so using precision and recall, one F1 matrix is created, that is equal to 2 into precision into recall upon precision plus recall. So F1 is used to measure the performance of the classification. Okay, this is the code using which you can find out the confusion matrix in Python. Okay, so this is the end of the classification. Now, if you have any question, you can ask.
Participants, please, if you are having any queries, then unmute yourself and ask the questions.
Hello.
Yes.
Madam, my question is that if my data is in Excel,
Hmm.
how I import data from Excel to Python?
Okay, for that, Python has a built-in function.
Yeah, ma'am.
If your data is in Excel, and if your wait a minute. Okay, I have shown you the program.
Yeah.
Hello. Hello.
Yes, ma'am, you are audible.
There is a read underscore Excel function in Panda library.
Hello.
Hello,
Madam.
Mr. Prashant.
Madam.
There is a read underscore Excel function in Panda library which can be used to load the Excel data into the data frame, data structure of Python.
How much data, madam, we can load?
The
Only one
complete,
Excel file or number of Excel file?
you can use number of Excel file also. There are, एक minute. Huh? There is a syntax there in the read Excel. If you want to load only one Excel file, that also possible. If you want to load multiple worksheet of Excel file, that is also possible.
Okay. Means data, number of data you can load, no?
Yes, yes, yes.
Number of rows and number of columns.
Yes. So
There
that
is
is
no size limit is not there, no?
the Excel file is loaded as a data frame, data frame.
Yeah.
And data frame has a number of rows and columns.
Okay. Madam,
Huh?
can you tell me the code for that?
Code. Yes, I will send you.
Yeah.
I'll send you the code for logistic regression, multivariate linear regression, and I'll send you that code also, how to load the Excel file.
Madam, one question is that in Python, can you run number of neural network?
Yes, that will be discussed in next session by Professor Chirag sir.
Okay. Okay, thank you very much.
Yeah, thank you.
Any other questions, please? Bharat Patel, sir, I think you was asking one question.
Excel RD is also one of the API that can be used to import the data from Excel to Python.
Yes, there are multiple way. The one way is using read Excel function of Panda library.
Okay.
So there may be other option also. Because Python is very huge, it is having very huge library. So you there may be many options available to you.
Yes. Okay.
Okay, ma'am. Then can we end the session, ma'am?
Okay, sir.
Okay. Thank you very much, ma'am. Thank you very much, ma'am. It was a really worth attending session. Thank you very much, ma'am.
Sir. Thank you.
Dear participants, so this is the end of the first session. We will start the second session at 12:15 p.m. Thank you all of you.